Hey everyone, I just wanted to run through this week's web work because I don't know, I feel like it might be really tricky for just getting exposed to the derivative rules. And since they changed the numbers, it'll give you something to reference. So here we go. Starting off with problem 1, we want to take the derivative of x times 12 to the x power. And so we should sort of think of this as we have something times something. Okay, I'm going to call it f times g. What I mean is f of x times g of x, where f of x is the function x, and g of x is the function 12 to the x. So then I want to follow the product rule, which says if you're trying to take the derivative of f times g, it's going to be f prime g plus g prime f. And again, all of these should have like x's, but I'm lazy. So, okay, let's just jump into it. Let me change my color. Sweet. So I'm going to do f prime, which is 1, times g, which is 12 to the x, plus g prime, which is the natural log of 12 times 12 to the x, times f, so times x. And there it is. There's my answer. I'm not going to worry about the 1 because times 1 doesn't change anything. Sweet. Let's jump to 2. And on problem 2, same idea. So I'm going to speed it up a little bit faster this time. We have x to the 7 minus x to the 1/8, all of that times 3 to the x. And so now this is my f, the whole thing in parentheses, and this is my g. So let's see, f prime, I do the power rule twice. That's 7x to the 6 minus 1/8 x to the negative 7 over 8. And that number is because I did 1/8 minus 1. But okay. Oops, I was right again, that's fine. So that is my f prime. I multiply it by g, which is 3 to the x. And then I have g prime, which is natural log of 3 times 3 to the x. And there's g prime. Times f, which is x to the 7 minus x to the 1/8. Sweet, so that would be my answer. All right, moving on to problem 3. We got our first exposure to the quotient rule. So we have 2t plus 15 divided by 6t plus 1. 6t plus 1. And we want to take the derivative of this. So this is in the form f divided by g, which I didn't really talk about much. You can figure it out by computing the derivative of f times 1 over g. Right, so when I write that, sorry, it's not g inverse. I mean like a 1 over g of x, which means whatever g of x is, so in this case, 6t plus 1, it's to the negative 1 power. So anyway, you could do it that way. Not going to worry about it. I'm just going to introduce the quotient rule. So if you have a function over a function, and you're going to take the derivative of it, so this is f of t, g of t, then it's the derivative of the top times the bottom minus the derivative of the bottom times the top all over the bottom squared. So that's the quotient rule. Let's just go ahead and use it. So I take the derivative of the top, so that's just 2. That's the derivative of this whole top, times the bottom times g, so that's times 6t plus 1, and I put that in parentheses because we need to let the reader know the 2 distributes, minus, and then I have g prime, so that's just 6. All that times f, which is 2t plus 15. Sweet. So all that is over g squared, so that's 6t plus 1 squared. And so that'd be the answer. So that's the quotient rule, which I didn't talk about much. So we'll just review it from here on out. Okay, another quotient rule. So I guess I'll just leave this up here. We got h of r is r to the 5th over 9r plus 12. And we're going to take the derivative of that with respect to r. So I do the derivative of the top, which is 5r to the 4th, times the bottom, so 9r plus 12, minus the derivative of the bottom, which is just 9, times the top, r to the 5th, all over the bottom squared. 9r plus 12 squared. Sweet. Next problem. So now another product rule. Not going to do it. We've done a couple of them now, so that's on you. Another product rule. You just do that one. All right, this one, let's go ahead and make it full screen or close to it here. What do we need? So use the figures, blah, blah, blah. Is that it? Sweet. All right. So let's see. We've got h prime of 1, and they tell us that h h is equal to f times g. So h prime of 1, you do the product rule, f prime g plus g prime f, and you plug in 1 everywhere. 1, 1, 1, 1. Right? This is, if you did h prime of x, you'd plug in a x everywhere. But we don't care about x, we care about 1. Right? So, all right. We need to figure out f prime at 1. So I look at my blue curve f, and at 1, I have to figure out the slope of that line. It looks like it goes over 3 and up 2. It goes over 3 and up 2. So I got that from looking at the graph. G prime at 1, that looks like it goes over 2 and up, over 3 and up 4. Okay. So G prime at 1 looks like it goes over 3 and up 4. Okay, whereas G at 1, I just have to read off G at 1. It looks like it's about 0.75. That's a little, wait, is that right? Let me see, 3. So this would be 2. Whoop, can't touch it. If that's 3, that's 2, that's 1. Oh, it says 1/2, I see. So 1, and that's 1/2, that's 1. So maybe like 1.25? That's kind of irritating that I have to guess, but fine, whatever. F at 1 looks like it's 0. Okay, so I get 2/3 times 1.25, and I'm actually curious enough to check, so let's go ahead and check that. All right, 2 divided by 3 times 1.25. Submit. At least 1. Oh, I have to do them both. Okay, let's do them both. So K is the quotient rule. Let's take a peek at K. K is F over G, so K prime is F prime G minus G prime F all over G squared. Okay, and if you want this at 1, you plug in 1s everywhere. Oh, so many 1s to write. I don't want to deal with it. Okay, so we need F prime. Oh, I should never erase that thing. F prime, it was over 3 up 2. So F prime at 1 is over 3 up 2. Oh, we want it negative 1. We want it negative 1. F prime at negative 1. Okay, try again. Let's see. That looks like it's over 1 up 2. G prime at negative 1. What's that slope? Let's see. 1.5 and 1. Okay, so that looks like it's... Okay, that's like what we had before. That's over 3 up 4. Over 3 up 4. Okay, G at negative 1. Sorry, all of these should be negative 1s. I don't want to deal with that. G at negative 1. Ugh, another estimate. Okay, let's see. Minus 1.25. And, oh, nope, that was F. That was F. The blue curve at negative 1. Is that right? Wait, or was that G? That was G. Blue curve and red curve. God damn it. F at negative 1 is negative 2. Okay, sweet. Let's put it all together. I'm so sorry you guys have to do this. This is such a pain in the butt. I can't believe I'm doing this. Y'all better thank me. Okay. We got negative 1.25 squared on bottom. That was my G, and I need to square it. Okay, and up top, we need to do F prime, so that's 2 times G, which is negative 1.25, minus G prime, which is 4/3, times F, which is negative 2, so I'll make that plus 2 over that. Oh, okay, let's try and enter this. So the 2 times the 4/3, that's 8/3. And then I'm taking away 2.5. And all of that, yes please, is over 1.25 squared. Sweet, so now let's submit. Oh, I don't like that. All right, well, I don't want to deal with it. You should use the product rule and quotient rule and read off the graphs accordingly. I'm not going to troubleshoot this. Let's look at the next one. All right, this is the same idea, but I don't have to read the graphs. So let me go through the idea one more time. That way I don't feel as guilty. All right, so G is equal to F times H. So that means that G prime at whatever spot you want is F prime at that spot times H at that spot plus H prime at that spot times F at that spot. Okay, so if that spot is supposed to be 3, then we should use the information we have. So, oh, this is prime. So let's see, F prime at 3 is 5, H at 3 is 3, and H prime and F, those are both 1. So it looks like I get 16. So let's go ahead and enter that real quick. What? Okay, let's try this. 1 sec. 1, 6. Great. And go away. Let's see, if we have G is F divided by H, then G prime is F prime H minus H prime F all over H squared. Okay, so let's use the information we have for G prime of 3. So F prime at 3 was 5, and then H is 3 minus, we're just sort of doing these same things, but, with a minus. So it's minus 1 all over, and then H is 3, so we need to do 3 squared. Okay, so that's 15 minus 1 over 9. So that's 14 over 9. What? 14? Why aren't you... Well, let's just try this. Hold on. Okay, type. There we go, 14 over 9. Okay, so that's the idea. I just didn't read the graph so carefully in the last problem. All right, product rule. I'm not going to go through it. We've done so many of these. Do the product rule. Next. Okay, product rule with a chain rule. That's probably how the last one was. Yeah, product rule with a chain rule. Okay, let's just real quickly. So I take the derivative of the first function, which is 4e to the 4x. And there's this, if you want the derivative of e to the kx, it's k e to the kx. And where this comes from, we can think of this as e to the k to the x power. And we have this exponential derivative rule that says you take the logarithm of the base times a to the x, so times the original function. So I should take the logarithm of e to the k, which this thing is k, times e to the kx. So another way to think of it is the chain rule, but these are all saying the same thing. So, all right, derivative of the first times the second, x squared plus 2x, plus the derivative of the second, 2x plus 2, times the first, e to the 4x, right? Product rule. Oh, I messed it up. This is supposed to be 2 to the x. Sorry, so this should be 2 to the x. We'll just kind of, goddamn, I need a tiny eraser. There we go, thank you, yes. 2 to the x, and similarly, no, u, plus parentheses, and right there I need to do natural log of 2 to the x. So, the derivative. Okay, look at the next one. Right, so do the product rule, and there's a chain rule on sine of 3x. I guess really quickly. So the derivative of 2x is 2, and I multiply by the first, sine 3x. So this is like my f prime g plus, and now I need to do, f g prime. So f is just 2x, but now g prime, I have to do the derivative of sine, which is cosine, keep the inside the same, times the derivative of the inside. Okay, so this was a chain rule, and I was looking at the derivative with respect to x of sine 3x. All right, chain rule, product rule, chain rule, product rule, chain rule. All right, let's take a peek at this one. Problem 14, so use the graph. All right, to find exact values indicated. The graph of f is in black and has a sharp corner x equals 2. The graph of g is in blue. All right, h is equal to f composed g, so let's talk about it. Fine. So this is a chain rule with reading the graph. H is equal to f composed g. So So h prime, we have to do the chain rule. It's f prime of g of x times g prime of x. So if we want h prime at 1, you should plug in 1. So what is g of 1? So that's the blue graph at 1. I don't know. G of 1, I suppose that is like 0.8. And that is fed into f prime. So we have to figure out f prime at 0.8 times, and then g prime at 1. G prime at 1. So times, and g prime, let's see, we go over 4, down 1. So minus 1/4. Okay. All right, now f prime at 8, we're going to use the graph. Sorry, f prime at 0.8. Looks like we're going over 2 and up 3. So over 2, up 3, times 1/4, that's 3/8. 3 divided by 8, enter. What? Oh, negative 3/8. I lost the negative. Okay, let's try this again. Negative 3/8, submit. Great. So same idea, but instead of using 1, we're going to use 2 and 3 for the next 2 exercises. So just remember, with this, we have g of 2. G of 2 is what you figure out, and then you have to plug that into f prime, right? We have a composition happening here. Okay, cool. Let's look at the next problem, and we're almost done. This is all the exact same idea. It's just recognizing when you have a derivative, you have to do the appropriate rule. So on parts B, D, and E, all of those care about h prime, and so you're either going to do like a chain rule or a quotient rule or something like that. Whereas if we were to look at A, so let's just do A for example, but sorry, C is also of this type, you just have to compute it. So for example, h of 4 in A is equal to f of g of 4. So what would you do? You would first figure out g of 4. So what is g of 4? It's 5. And then that's what f sees. So what is f of 5? It's 6. So the answer is 6 for A. All right. And then with the other ones, I guess I'll do B as an example here and then leave you to the rest. So B, we have h prime of x is, and we do f prime at g of x times g prime at x. Okay, so h prime, get rid of these, at 4 is f prime at g of 4 times g prime at 4. Okay, so this is f prime at, and now g of 4 is 5, we saw that earlier, times g prime at 4, which is 4. And now f prime at 5 is 6. So this is 6 times 4 is 24. Okay. So that's how you do those problems. All right, next up, simple chain rule. You got this. Okay, chain rule with a quotient rule. So look, the derivative of tangent is secant squared x. Okay. But you don't actually need to know that. Tangent is the same thing as sine of x over cosine of x. And so when you do this, you should do a quotient rule. The derivative of the top is cosine times the bottom, which is cosine, minus, and now the derivative of the bottom is a negative sign. So I got negative sine, right? Did a little sign change, times the top. So we got a cosine squared plus sine squared all over the bottom squared, which is cosine squared. And cosine squared plus sine squared, that is 1. And 1 over cosine squared is exactly what secant squared is. Secant is 1 over cosine. Squaring is 1 over cosine squared. So anyway, okay. G prime of t. You could think of this as you need to take the derivative of sine of the natural log of t over cosine of the natural log of t. And that is a quotient rule with a chain rule. Okay, that's totally fine. But if you're comfortable with the derivative of tangent, Then this is the derivative of tangent, which is secant squared, and you leave the inside the same, natural log of t, times the derivative of the inside, which is 1 over t. Okay, so that's that one, and I think that's the last one. Nope, maybe not. What's going on? Next problem. Thank you, 18. Okay, this is the last one. Now we're grayed out. Sweet. Okay, let's see. So we have the spot 2, 6, whoop, 2, 6, and some other spots, 2.2, 6.3. So by the way, the slope of this line is 0.3 divided by 0.2, which is 3 over 2. Sweet. Now the slope of that line, let's see, the graph is f. So this thing here, this is f. So f prime at the x value of 2. So f prime right here at the point of tangency is the slope of that line, which is 3 over 2. Okay, that might be useful. Whereas f at 2 is equal to 6. That's why there's a 6 there. That's why that point is a point of tangency. It lies on your curve. Okay, so those two things will be useful. Now we have h prime is equal to, and this is h prime of x. So I need to do the chain rule. The derivative of the outside is the power rule. I leave the inside alone, then I take the derivative of the inside. Okay, so h prime at 2 is 4f at 2 cubed times f prime at 2. And we figured this out. This is 6 cubed times 4, and f prime at 2 is 3 halves. And so, using this information, you can fill all that out. Okay, now there's the harder one. And it says g is equal to f inverse. So g of x is f inverse of x. And then it asks, what is g prime at 6? Okay, so this is really slick, and I'll just give you the answer first. And if that's all you care about, then you can stop there. So it turns out it's 1 over f prime at 2. And saying g is f inverse, the fact that f of 2 is equal to 6 is the same as saying g of 6 is equal to 2. And then it turns out the way derivatives of inverses are related is they're reciprocals. So that's where this formula comes from. You sort of take a reciprocal, but of the right spot. So this is 1 over, and then f prime of 2 is 3 halves. So that's the same thing as 2/3. But okay, now let me explain that a little bit better. So the inverse function, if you have some curve, whoop, and then here's the line y equals x. Sorry, not y of x, y equals x. And here's y equals f of x. Then f inverse is what happens when you reflect along the line y equals x. So this is supposed to be a reflection. And so on the curve f, we know that f of 2 is equal to 6. So it has this spot 2, 6. And it turns out if you reflect over the line y equals x, that's just swapping. Okay, so this doesn't look like it. So maybe I should make one that looks more like it. You know what I should do is, shit. Well, that's not what I should do. Okay, I should change these names based on the information I have. So this is going to be f of x, and this is going to be f inverse. So it's still just a reflection, but now I can say, okay, this is not the 0.26. So go over 2 up 6. Nope, that's not what I want. Go, Sweet. So maybe this is the 0.26. And then when I reflect it over the line y equals x, this will be the 0.62. And right. So f of 2 equals 6. That's where that comes from. Whereas g of 6 equals 2 is where that comes from. So, all right, if you have a tangent line right here, then it'll go to one right here. And it, since we're swapping y and x, then the slope of this line, it's some change in y over change in x, or some like y2 minus y1 over x2 minus x1. But when you swap it, that's like writing x2 minus x1 over y2 minus y1, because I'm literally going to swap, like, you know, how 2, 6 became 6, 2, I swap all the x and y values. So what used to be x2, y2, like some spot here, goes over here, and now it's y2 comma x2, where I'm referring to the numbers. So what? So the change in y between like these 2 points is the same as the change in x between these 2 points. So this distance here is the same as this distance here. Change in y becomes change in x. All right. Anyway, that's all to say that what used to be the slope of the tangent line of f, it now looks like this, which is, if I call this m, it's 1 over m. It's 1 over that slope. Okay? So if you followed that, more or less, then you just have to realize this slope is f prime at 2, because there the x value is 2. But the one that it corresponds to on G, we had to switch x and y, so this is G prime at 6. So f prime at 2 and G prime at 6 are related, and G prime at 6 is 1 over f prime at 2. So here's f prime at 2, because you flip the slope. So anyway, I can talk more about that in person or link some videos, but that's what's going on in problem 18. So, all right.